Hello everybody, welcome back. This is Esther here and welcome to my channel. Today we're going to be studying chapter 8 quadrilaterals, and this is an introduction session part 1 to this chapter. So today we're going to be seeing half of this chapter, that is we're going to be seeing all the concepts in this chapter, but we're going to only be seeing a half of it, and the next session we're going to be seeing the other half of this chapter. Okay, so if you're new to my channel, please make sure to like, share, and subscribe. And if you found this video helpful, please make sure to check out all the other videos on my channel as well. Okay, guys, so let's get started. Now, this chapter 8 quadrilaterals, okay, it tells us definitely a lot of things about types of quadrilaterals. But in the first place, what is a quadrilateral? So, quadrilateral is a closed figure. It's a closed figure with 4 sides, 4 angles, and 4 vertices. Okay, so any closed figure, this can be any closed figure with 4 sides, 4 angles, and 4 vertices. Let's take this figure. Now here you can see this figure has 4 sides, 1, 2, 3, 4, and it has 4 angles, 1, 2, 3, 4, and 4 vertices. Vertices are what? They are places or points where 2 lines meet. This point is called as a vertex. Okay, so we have 1, 2, 3, 4 vertices. Clear? So what is a quadrilateral again? A closed figure with 4 sides, 4 angles, and 4 vertices. I hope that is clear. Moving on, let us move to the types of quadrilaterals. We have understood what is a quadrilateral. Now let us see the types of quadrilaterals. So we have here 7 types of quadrilaterals, and I'm pretty much sure that you have studied about these types of quadrilaterals in your previous year. I think there was a chapter itself to this quadrilaterals where you studied in detail about the different types of quadrilaterals, theorems, etc. So in this chapter, we're not going to be going into details of all the quadrilaterals, but we're specifically looking to the details of some quadrilaterals. Okay, so let's just generally know about the types of quadrilaterals. So firstly, we have here a parallelogram. Okay, parallelogram. Oh my god, sorry for the spelling error. Yes, so parallelogram, or I suggest that I'm writing it like this for now. This side means same as parallelogram. Okay, so what is this parallelogram? This parallelogram is somewhat like this. Okay, let's say this is A, B, C, and D. Now a parallelogram is a quadrilateral where the opposite sides are equal and parallel. This sign stands for what? Parallel. Okay, so these two sides are equal and parallel, and these two sides are equal and parallel to each other. Clear? Now also the opposite angles, this stands for angles. Okay, opposite angles are parallel and equal. Okay, are parallel and equal. So sorry, no, the angles are not parallel, the angles are only equal. Okay, the angles are only equal, they're not parallel. So angles means this angle and this angle are equal, this angle and this angle are equal. Guys, please make sure to note down all these important things, and please take a notebook and write down all that I'm writing here on the screen, or whatever you feel is important in this session, because these properties of the types of quadrilaterals will be very helpful when you're solving the exercises. Okay, they're going to be coming in handy during those times. Now opposite angles are equal, opposite sides are equal and parallel to each other. So also remember that the diagonals, what are diagonals? The lines that join the opposite vertices of a quadrilateral, they are diagonals. So these diagonals of a parallelogram bisect each other. Like for example, let me just use another ink here. Like if I join D to B and A to C, now here AC and DB are what? Diagonals. Okay, they are diagonals here. Now these diagonals bisect each other, meaning first they meet at point O here. Okay, let's say this point is O, and they bisect each other, means they divide each other into equal halves. Like this is equal to this and this is equal to this. Okay, see, these lines mean that they're equal to each other. Okay, so AO is equal to OC, so that means according to this part, AO is equal to OC and BO is equal to OB. That's the meaning of this line, that diagonals bisect each other. Clear? So these are the properties of a parallelogram. Briefly, I'm telling you. Okay. Now, the second thing is rectangle. Rectangle. I'm sure you all are aware of how a rectangle looks, right? So a rectangle looks somewhat like this. A, B, C, D. Okay, so in a rectangle, the opposite sides are equal and what? Equal and parallel. Opposite sides are equal and parallel. Then also we can say that the all four angles are 90 degrees. All four angles are right angles, right, or 90-degree angles. Clear? Like here in this figure, opposite sides are equal and parallel, means this side is equal to this side as well as it's parallel. This side is equal to this side as well as it's parallel. Second point is all four angles are right angles, means all these are 90 degrees, right? These rectangular boxes tell us that all four angles are 90 degrees. Also, you can get to see that the diagonals bisect each of its vertex angle. Okay, so here you can say that the diagonals bisect each other. Diagonals bisect each other. Diagonals bisect each other and are equal. Okay, diagonals bisect each other, meaning here you know that AC and DB are the diagonals, right? So these diagonals meet at point O and they bisect each other, and as well as they're equal. So this statement means that AC is equal to DB as well as AO is equal to CO and DO is equal to OP. Clear? So this is all about rectangle. I hope these points are clear to you. Moving on to the next type of quadrilateral. So next is the third one. Okay, we don't use this symbol. Hold on. Okay, now the third one is square. Okay, square is also one of our familiar quadrilaterals. So I have here A, B, C, D, square. Okay, now in this square has what? All sides are equal. I'm sure you all are aware of this, right? All sides are equal and opposite sides are equal and parallel. That is also there. Okay, so that is also kind of covered in the previous point itself, right? So let's move on to the next one. So all angles are 90 degrees. We all are aware of that. So all angles are right or 90-degree angles. So let's just see these 2 points in the figure, shall we? All sides are equal to each other. Okay. All sides are equal to each other. All angles are 90 degrees. Okay. 90 degrees. And you have to remember that the diagonals bisect each other at 90 degrees. Meaning you can say that the diagonals bisect each other and are perpendicular to each other. Okay. Or I'm just writing in simple words, the diagonals bisect each other at 90 degrees. Clear? So let's just mark that in the figure. Here AC is your diagonal, DB is also your diagonal, meet at point O. Now they bisect each other at what? 90 degrees. Clear? So this statement means AO is equal to CO and DO is equal to OB at 90 degrees, or you can say a right angle. Clear? So this is all about square, the third type of quadrilateral. Okay. Moving on to the next type of quadrilateral. Okay, let's change the color. Yeah, fourth one, which is nothing but trapezium. Now trapezium looks somewhat like this. I think you all must be knowing that. A, B, C, D. Okay, trapezium. Now in this we know that only one point is there, that opposite sides is parallel. Okay, opposite sides are parallel to each other. So this one is parallel, only parallel. Okay, they're only parallel to each other. And also remember that suppose, let's say the non-parallel sides, oh I'm really sorry, yeah, suppose the opposite sides which are non-parallel to each other, suppose if they are what do you say, if they are parallel to each other, then we can say that this figure will become a what? Isosceles trapezium. Let's again change the color. Yeah, isosceles trapezium. If suppose the non-parallel sides are parallel. Okay, meaning like if this is your trapezium, that means a non-parallel sides, which is AD and BC. If these are parallel to each other, it will become a isosceles trapezium. Clear? Now moving on to the next quadrilateral, which is the sixth one, is rhombus. Now rhombus is also like kind of square, you can say. I mean, it looks kind of like a square, you can say. So rhombus looks somewhat like this, right? Close to that. So A, B, C, D is a rhombus. Okay. Now here in this rhombus, we know that all sides are equal. All sides are equal to each other, right? So this is equal to this, is equal to this, is equal to this. All sides are equal, as well as opposite angles and sides are equal to each other, right? Opposite sides are equal and parallel, you can see opposite sides are equal and parallel, as well as opposite angles are equal to each other. Clear? And as well as you can say that the diagonals bisect each other at right angles. So that means here opposite sides are equal and parallel, opposite angles are equal, this angle is equal to this angle, this angle is equal to this angle. Diagonals bisect each other at right angles. So AC and DB are bisected at point O at 90 degrees. Clear? Became kind of shabby, but I'll just write what the statement means here. So AO is equal to CO and DO is equal to OB at 90 degrees. Clear? So this is all about rhombus. Very important points, all of these. Clear, guys? Now moving on to the last type of quadrilateral, that is kite. You all have heard of kite, definitely. You all have definitely fl even flown the kites in the sky, right? And it's really fun, isn't it? So we are going to learn about that kite now. So kite. Now kite looks something like this, right? Yeah. So A, B, C, D. This is a kite. Now in a kite, only one property we are going to learn, that the two pairs of adjacent sides are equal to each other. Clear? So two pairs of adjacent sides are equal means this side is equal to this side and this side is equal to this side. Clear? So I hope you understood all the properties of all the types of quadrilaterals. Now let us move on to the next part. Next we are going to move on to a theorem, guys. Okay, theorem. Now this theorem is very important, which is the angle sum property of a quadrilateral. Now in chapter 7 we've learned about angle sum property of a triangle. Chapter 6 also we learned that. I think in chapter 6 only we learned it. Sorry, chapter 7 we didn't learn that. Chapter 6 we learned the angle sum property of a triangle, right? So that means what? If I have a triangle, let's say I have A, B, C. That means according to angle sum property of triangle, angle A plus angle B plus angle C is equal to 180 degrees. This is angle sum property of a triangle, isn't it? But here we're going to be studying about the angle sum property of a quadrilateral. Clear? So basically, in simple words, what is the angle sum property of a quadrilateral? Tell us. It is basically the sum of all angles will give rise to 360 degrees. Sum of all four angles, because it's a quadrilateral after all, right? So let's construct a figure, like for example this one, A, B, C, D. Now according to this angle sum property, we can say that angle A plus angle B plus angle C plus angle D is equal to 360 degrees, right? Now let me share with you the proof of this theorem. So first steps, let us first write what we have to prove. What we have to prove? We have to prove that angle A plus angle B plus angle C is equal to 360 degrees, right? And for this, we're going to do a small construction. What we are going to do, we are going to join BD. BD we are going to join. Okay. We're going to join B to D. Join BD. Clear? Now, let's see the proof to this. Before we start with the proof, let me just name the angles so that we won't have the confusion stuff. So let's say this is angle 1, angle 2, angle 3, and angle 4. Now proof is, first of all, we know that in a triangle, angle A plus angle in a triangle, let's say angle in triangle ADB, angle A plus angle B plus angle D is equal to 180 degrees. Okay, and this is what angle sum property of triangle. Clear? So let's take this to be equation number 1. Okay, and before we write equation number 1, let's just substitute the names of angle D and angle B here. Okay, so angle A is going to remain as angle A plus angle B here. What have I named it? Sorry, angle ABD, what have I named it? It is angle 1 plus angle ADB is what? Angle 3, right? Which is equal to 180 degrees. Now take this as equation 1. Similarly, in triangle DBC. Angle D plus angle B plus angle C is equal to 180 degrees, again because of angle sum property of triangle. Clear? So angle D is angle BDC is equal to angle 4 plus angle DBC is equal to what? Angle 2. When I'm talking about angles, right, angle, sides, and all of these things, please make sure to look at the figure so that you would stay put and you would understand what I'm talking about, right? Cool. So plus angle C is going to remain as angle C. This is equal to 180 degrees. This is equation number 2. Okay, let's just write that a bit more neatly. Okay, this is equation number 2. I'm erasing this portion. Okay, so okay, I'll write the rest of the proof here on the side in a different ink. Okay, so let me just write it here. Okay, now we have got equation 1 and equation 2. Now add equation 1 plus 2. Okay, add equation 1 and 2. So what is equation 1 and 2? Here you know this is equation 1, this is equation 2. Let's add the LHS first. What is LHS? Angle A plus angle 1 plus angle 3 from equation 1 plus angle 4 plus angle 2 plus angle C from equation 2. This is equal to RHS will be what? 180 degrees plus 180 degrees, right? Both equations have RHS as 180 and 180. So this is equal to 180 plus 180. Now let's add the LHS. I mean, let's just arrange it in order. Now angle A plus angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle C is equal to what? 180 degrees plus 180 degrees. Now what is angle 1 plus angle 2? Here look at the figure. Angle 1 plus angle 2 is angle B, right? So angle A plus angle B, let's say, instead of angle 1 plus 2, plus angle 3 plus angle 4. What is angle 3 plus angle 4? This is angle D, right? So angle D plus angle C is equal to what is 180 plus 180? This is 360 degrees. Now let's arrange these angles in order. So excuse me, I'm so sorry, excuse me. So angle A plus angle B plus angle C plus angle D is equal to 360 degrees. I've arranged the angles in order. This is equal to 360 degrees. Now what did we have to prove in the beginning? That angle A plus angle B plus angle C plus angle D is equal to 360 degrees, and that's what we have proved right here. So thus proved. Clear? Very simple, right? Very easy. I hope you guys got it right. So what did we do? First we constructed did a small construction, that is we joined D to B, and then we said that we applied angle sum property of triangle in both triangle ADB and DBC, and then we just added these two equations, and that's how we got angle A plus angle B plus angle C plus angle D. Clear? I hope this thing was clear to you. I hope you guys understood it, right? Great. So now we are going to move on. Oh my god, I'm so sorry, I'm scratching it up by mistake, man, seriously. Okay, now let's move on to the next part, which is a very, very important thing. And here we are going to be discussing the properties of a parallelogram. The properties of a parallelogram. Okay, just few more minutes, guys, and we will wind up this session. Okay, so we're going to be discussing a couple of theorems about which we have already learned before, right? Like in the beginning I told you the about a parallelogram. Similar, we're going to learn the same things here, few more additional things also about this. And whatever theorems I'm going to be writing from now on, please learn its proof if I've given a proof to it. Okay, so first we're going to start with theorem number 1. Theorem 1, or you can say in other words theorem 8.1. See, always remember, guys, suppose in a particular question, if you're applying any of the theorems, not only for a parallelogram but any theorem which you're applying, don't write in the bracket this is because of theorem 8.1. Don't write like this. Suppose you're going for public exam and you're going to write in the bracket theorem 8.1. How will the examiner know which theorem are you talking about? Please don't do that. Instead, you should write the complete statement in the brackets. Okay, instead of writing theorem 8.1, please don't write the numbers and all of that. You're supposed to mention the whole statement. So for that, now itself, whenever you're doing the questions and when you're practicing it, please start to write the statement in the brackets. Even if you're not able to memorize it in the first time also, please try to continue to keep writing it, so that you will get a habit. And don't worry, you will learn it as time goes. In one overnight, no one can learn anything, right? So keep practicing and you will get it. Now theorem 8.1, what does it say? That diagonal of a parallelogram divides it into two congruent triangles. Okay, so meaning, like suppose I have a parallelogram here, A, B, C, D. The diagonal, let's say diagonal DB, it divides this parallelogram ABCD into two congruent triangles ADB and DBC. This is what we have to prove, right? So what do we have to prove? Let's see the proof to this theorem. What do we have to prove? That triangle ADB is congruent to triangle DBC. Are you understanding what we have to prove? We have to show that the diagonal of a parallelogram actually divides the parallelogram into two congruent triangles. Clear? So that's what we have to prove. Now let's say the proof here. So proof is, we just need to prove that these two are congruent. Let's see how to do it. So in triangles ADB and DBC, very simple, I can say that angle ADB, what is angle ADB? This one is equal to angle DBC, that is this one, right? So these are what? Alternate interior angles. And angles, since BC is parallel to AD, right? BC is parallel to AD. Similarly, angle DBA is equal to angle CDB, again because of alternate interior angles, but this time DC is parallel to AB. Okay, so alternate interior angles, like that we're saying. Also we can say that DB is equal to DB. Why? Because it is the common side. So which congruency rule are we using here? We are using ASA congruency rule. Why? Because angle side. So here you can see that in the figure it is coming angle, this angle is equal to this angle, then this side is also equal, and this angle is equal to this angle. So it will become angle side angle. Okay, so angle side angle. So therefore, if you haven't understood what is this congruency all about, please check out our videos about chapter 7, okay, where we have explained all about this like how to do the congruency and everything in detail. Okay, there you can easily understand how to prove the triangles congruent. So therefore, by ASA, we can say that triangle ADB is congruent to triangle DBC. Clear? So this is how we proved that this theorem is valid. So I hope theorem 8.1 is clear. Let's move on to the next theorem. Okay, so what's the next theorem? The next theorem is theorem 8.2, which says in a parallelogram, opposite sides are equal. Okay, so let's take a parallelogram. A, B, C, D. Okay, in this opposite sides are equal, meaning this side is equal to this side and this side is equal to this side. Clear? So In a parallelogram, opposite sides are equal. There's no proof for this theorem, just a statement in this. Now next comes theorem 8.3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Now here you can see that, see in theorem 8.2, in a parallelogram opposite sides are equal, but this theorem 8.3 is a converse of theorem 8.2. What does that mean? Meaning it's the opposite of theorem 8.2. That is, if in any given quadrilateral, if each pair of opposite sides are equal, then we can say that that quadrilateral can be called a parallelogram. Clear? So that's a converse of theorem 8.2. Clear? Now moving on to theorem 8.4. Okay, theorem 8.4, it says in a parallelogram, opposite angles are equal, right? So opposite angles are equal means this angle, look at the figure, this angle is equal to this angle and this angle is equal to this angle. That's what it means. Clear? Now moving on to theorem 8.5, I'll write it here itself. So theorem 8.5 states that in a quadrilateral, if each pair of, this is pair, okay, by the way, okay, each pair of opposite angles is equal, then it is a parallelogram. Okay, so that means again this is the converse of theorem 8.4, right? So meaning in theorem 8.4, what is it saying? In a parallelogram, opposite angles are equal. But in theorem 8.5, they're saying that in any given quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. Okay, that particular quadrilateral is a parallelogram. I hope that is clear. Now let's move on to the next theorem. For some variation, let's choose another color. Sorry. Yeah. Now theorem 8.6, right? Yeah. Theorem 8.6. The diagonals of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. So if I have a parallelogram here, A, B, C, D, the diagonals A, C, and B, D bisect each other at point O, like AO is equal to CO and DO is equal to OB. That's the meaning of theorem 8.6. Clear? Now, theorem 8.7, what does it say? Theorem 8.7, if diagonals of a quadrilateral, oh my god, just one second. See this sign, right? This sign means that it's just a repetition of the words written above. So if diagonals of a quadrilateral, I think you all know this, right? Yeah. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So this is a converse of theorem 8.6. So basically, what is theorem 8.6 saying? Diagonals of parallelogram bisect each other. But here in theorem 8.7, they're saying if diagonals of a quadrilateral, any quadrilateral bisect each other, then that particular quadrilateral is a parallelogram. Clear? Last but not the least, here we have theorem 8.8. Okay, I mean last but not the least means for this session. Yeah, so for this session, theorem 8.8, which is the last theorem we're going to be learning under the properties of a parallelogram. That is a quadrilateral, that is any quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. So any quadrilateral is a parallelogram if a pair of opposite sides, any pair of opposite sides is equal and parallel to each other. This is like the first, not the first theorem, but the like theorem 8.2, 8.3, like that, similar to that. Okay, so this is the end of this session, guys. Theorem 8.8. We're winding up with this. In the next session, we're going to be discussing the last two theorems of this chapter, as well as the in like that completes the introduction to this chapter. We're going to be learning the midpoint theorem, very important theorem, because exercise 8.2 is based upon this theorem, as well as one more theorem also, theorem 8.10. So that's what we are going to be seeing, right? So that's what we're going to be seeing in the next session. I hope you guys enjoyed this video, you understood the concepts, right? If you have any doubts, please feel free to use the comment section down below to drop your comments and doubts there. And if you found this video helpful, please make sure to like, share, and subscribe. And please make sure to share with your friends, guys, so that this video would get more views and my channel would get more subscribers. Thank you guys so much for watching this video, and see you all in the next session, guys. Once again, take care of yourselves. Bye bye. See you all in the next session. Bye.